Hey everybody, we're moving on to our next video. This is on muscles and motor units. By the way, hang on. There's Mrs. B back there. Yeah, there you go. Okay. Moving on to motor units, also looking at isotonic and isometric contractions and what is muscle tone. So, as we start with this, and there goes Mrs. B.
Bye.
As we start this, looking at motor units, we discussed in class already the idea that nerves are going to innervate, that is, control muscles. But what's this idea of a motor unit? First, let's start with this idea of a nerve. A nerve is going to be a collection or a bundle of axons. So here you see motor meaning to control, voluntary control, to control the muscle contractions. So coming out of this nerve, we see two individual neuron axons, right? This one happens to go to this muscle fiber and to this one. This motor unit muscle fiber, the motor neuron is going to come here and there and there. So a motor unit is going to be a neuron, that is a nerve cell, and then all the muscle fibers it controls. So motor unit 1 happens to control 2 different muscle fibers. Motor unit 2 controls 3 different ones. Now, before we go any further, a contraction strength is going to be related in part to how many motor units are going to be activated in a muscle at a given time. We'll look more at the strength of muscle contractions in class. But part of the strength of a muscle contraction is how many muscle fibers are going to be stimulated. So a motor unit, again, is a neuron and all the muscle fibers it controls. So by control, if this neuron happens to fire, these three particular muscle fibers would fire. If this one fired, just those 2. If both of these fired, then all 5 of these muscle fibers would contract. So again, a motor unit is an important property in physiology because it means the neuron and all the muscle fibers that particular neuron controls. But then consider this relationship. What's the relationship between the number of muscle fibers and coordination or fine movement, fine control? The average motor unit, as you see here, has about 200 muscle fibers per neuron, per motor unit. Think about a large muscle first. Think about something like the gastrocnemius. Here, we don't need fine, coordinated, smoothly tuned movement. We need powerful movement. So here you may see 1,000 muscle fibers are controlled by one neuron. When that neuron fires, 1,000 different muscle fibers are going to contract. Okay, that's going to be for strength. But think about the muscles in your eye or your fingers. You don't need a lot of strength, you need delicate movements. So smaller motor units, like you see here, give you fine degrees of control. So if you only have 3 or 6 muscle fibers controlled by a single neuron, when that one fires, just a few muscle fibers are going to fire as a result. So think about small motor units being for delicate coordinated movements. Large motor units are going to be for more strength and less about control. Okay, a couple more topics I want to touch on here. One that tends to confuse students a little bit, and let me move over here, is the difference between isotonic and isometric contractions. The reason this confuses you is because you assume every time a muscle tries to move, it can move. So let's back up a little bit. Okay, this is an example of a muscle. You see a tendon here, and here is a 3 kilogram weight. So what happens is, as this muscle is stimulated and it begins to contract, it begins to, first it begins to develop a tension. It begins to get tension, but at the myosin actin, they begin to develop across bridges, and tension increases. If that tension actually is enough to overcome the load, then in this case, this muscle shortens, and this is an example of an isotonic contraction. The muscle shortens because actin and myosin actually, well, actin slid past myosin, because in this case we could overcome the load. We can get enough force in that muscle to make that muscle contract and pull the load. That's an isotonic contraction. Isometric is a little different. Okay, isometric here, okay, we need to have, let's see, it's hard to see down here, it's cut off. This is a 6 kilogram weight, it looks like, or maybe it's 8. This muscle is going to start to contract. It's being stimulated, but the strength of the contraction is not enough to overcome the load. So as you see here, it doesn't change its length. It doesn't change shape. If you try to lift something very heavy like a car, you may have muscle contractions, but you're not going to get the full range of shortening because the load's too heavy. You're still having myosin interact with actin. It's just nothing is sliding in that case. So isotonic contractions are when you have enough force to overcome the load and you can have sliding of the filaments. That's an isotonic contraction. Isometric is you develop a tension because myosin and actin bind, but there is no sliding because the force is too great and that muscle can't overcome that load and it can't shorten. All right, and one final topic here is muscle tone. This is also a little confusing to people because, again, we tend to think that we control all of our muscles all of the time. And actually, in this case, we're going to have some unconscious nerve impulses. These are spinal nerve reflexes that provide some tension. Even you see here some definition of her muscles. Provide some definition, some tension on the muscles, even when we're not really controlling them. That is, we get some partial contractions of our muscles because of spinal reflexes. And why would you want to have your muscles slightly and partially contracted? So that if you have a sudden movement or you have a sudden push or pull or you're trying to maintain your posture or balance, you don't want to go from a completely weak, completely relaxed muscle to try to develop the tension fast enough to catch yourself before you fall down. So we have what's called a near continuous innervation. Fancy science talk for we have a constant nerve signal being sent to our muscles to provide a little bit of tension, a little bit of definition, even when we're not voluntarily controlling it. That is called muscle tone. That's it for this video. Thanks.